A 2.4 meter diameter cylinder plugs a rectangular hole in a tank that is 0.9 meter long. With what force is the cylinder pressed against the bottom of the tank due to the 2.7 meter depth of water? So with the presence of 2.7 meter depth of water, this cylinder will be pressed downward, but we'll just compute the reaction, then we'll just reverse the direction later. So this is the given information. The width of the opening is to be computed. Anyway, we are given this information 30 degrees and the radius is 1.2 meter. So supposedly the contact point should be circular. The contact point should be linear, perpendicular to the board. So we divide the contact points into two parts. This point and that point, this point and that point, and this curve here. So first, by principle, for the vertical component, horizontal, it will be in equilibrium. We draw vertical lines from these endpoints of the curve, excluding this because there's no contact with liquid here. Just this part here, and we will divide this into two parts, this and the upper part. So we also draw line from here to the liquid surface. So by principle, the FV net would be the volume bounded by the vertical lines to the liquid surface and this curve. So since there are two parts, this one, so this is the net area to be considered, and the force is upward. So this is the area to be considered, and we have another area here, so we just double the area later. Then for this curve here, this falls under case 2. The liquid is under the curve. That's why the force is upward. But for this curve here, this is case 1. The liquid is over the curve, so the force is downward due to the weight of water. So we will call that FV1. And for the weight of water above this curve, because these are the endpoints of the curve and we draw vertical lines up to the liquid surface, and it falls under case 1, the liquid is above the curve, so it is downward, and we will call that FV2. So the force that tends to press this cylinder is FV2 minus FV1 supposedly, but we'll just compute the reaction. Supposedly these are the reactions. I'll call that FV or F. Then whatever the magnitude of F, we'll just reverse it. It should be downward because that's the reaction supposedly. So F plus FV1 equals FV2. So how to solve for FV1? FV1 is, we need to compute this area here. So that's Y and Y, 30 degrees. So this is 60 degrees. So this area here, that's 1.2, the radius. And let's call that X. The area here is area of sector with central angle 60 degrees or pi over 3 radians minus area of triangle with central angle 60 degrees. So that's the area. Cosine of 30 degrees is x over hypotenuse 1.2. So x is 1.039 meter. We need that in computing FV2 later. So this is the sector of central angle 60 because that's another 30 degrees, radius 1.2. Then we subtract the area of triangle of central angle 60. And let's call that area. So area is area of sector 1/2, radius 1.2 squares, then central angle in radians pi over 3 or 60 degrees, minus area of triangle 1/2 product of adjacent sides 1/2 1.2 square 1.2 times 1.2, then sine of the included angle, which is 60 degrees. So area is 0.13044 square meter. So I hope it's not a problem in computing the area of the segment of a circle. You are now in fluid mechanics and hydraulics, higher subject, so you're through with geometry. That's no longer a question. It's a very big problem if you still do not know the area of a segment of a circle. So double that area because we have the same area here. Then FV1 is specific weight of water times volume. The volume is simply area times length perpendicular to the screen, which is 0.9. So FV1 is specific weight of water in newtons per cubic meter, area 0.13044 times 2 because we have two areas here in computing FV1, then perpendicular to the board 0.9. So that is the volume. So 2303 newtons. Then for weight of water, FV2, we draw this horizontal line, and that let's compute for this height first. This is 2.7 minus 2y, and y is from the figure 1.2 sine of 30. So h1 is 2.7 minus 2 times y, and y is 1.2 sine of 30 degrees. So h1 is 1.5 meters. Then we draw this horizontal line. This is 2 times x, 2 times 1.039, the dimension of this rectangle. Then the area to be considered in computing for FV2 is area of rectangle with dimension 2 by 1.039 by height h1 less area of another segment of a circle, call that area 1, which is area of sector again with central angle 120 degrees because this is 60 and another 60 degrees here, so 120 degrees, minus area of triangle with central angle 120 degrees also. So area 1 is 1/2 1.2 square 120 degrees or 2 pi over 3 radians minus area of triangle 1/2 1.2 square sine of 120 degrees. So just imagine we have a sector of central angle 120 degrees, then less triangle of central angle 120 degrees also. So area 1 is 0.88443 square meter. FV2 is specific weight of water times volume, and the volume is this area of water here times 0.9 perpendicular to the board. And this area of water section is area of rectangle 2 times 1.039 by h1, 1.5, minus area 1. So FV2 is 9810, 2 times 1.039 horizontal dimension of rectangle height 1.5 minus area 1. So that's the area of the water section above this curve, then times perpendicular to the board 0.9. So FV2 is 19711 newtons. Finally, substitute here. F plus FV1, 2303 equals 19711. So F, that's the reaction, but the question is with what force is the cylinder pressed against the bottom of the tank? It should be the opposite, so it should be downward. So F is 17408 newtons down. So that is the force where this cylinder is pressed due to the presence of 2.7 meter deep of water. So that's it.